This week we will be looking at properties of logarithm. And so the first property is the product rule. And the product rule states that if you have a log and you're multiplying two positive real numbers, we can separate it as addition as log bm plus log bn. The quotient rule, if we're dividing, then we can separate it as log bm minus log bn. And then the last rule that we'll look at here is the power rule. And the power rule states that we can take our exponent p and bring it to the front of the logarithm. We use these rules to expand each of the logarithms. So for the first one, we have log 6 3 raised to the power of 9. Since I have an exponent, then I can bring the exponent to the front. And I would get 9 log 6 of 3. Okay, the next one we have 7 times 11. So we can separate this as log 6 of 7. Since we're multiplying, we'll be adding, so this would be log 6 of 11. For the third one, we are dividing 23 divided by x. So we can separate this as log 823 minus log 8 of x using the quotient rule. For number 4, the 100 and the x are being multiplied. So we can write that as log 100 plus log of x. Now log 100, since this is a base 10, we can enter that into our calculator. And that's going to be 2 plus log x. So let me demonstrate that with the calculator. Okay, so here we would have log of 100, enter, so we get 2. Okay, so the next problem, we have natural log of e to the 5th power minus natural log of 11. But notice that we have an exponent, so we can bring the 5 to the front. So we have 5 natural log of e minus natural log of 11. Now the natural log is the same as saying log of base e of e minus natural log of 11. Since this base is e and this is also base e, then the property that we can use here is that this is going to be equal to 1. So my answer here would be 5 minus natural log 11. So sometimes people just like to cancel out the ln and the e, but the reason we can do that is because they have the same base. Okay, so the next one here, I can take my power to the front, so I get 2 log of x plus 4. So here we were using the rules to expand our logarithm. So we started with 1 logarithm, we ended up with 2, for example. So let's look at number 7. So here we're multiplying, so we can write this as log b of x to the 4th plus log b of the cube root of y. I can bring the 4 to the front using the power rule, plus anytime you have a root, we can write it as with a fraction. So the cube root will be a 1/3. So this would be 4 log b of x. I can bring the 1/3 to the front of log b to the y. So again, anytime you have a root, you can change that as an exponent. Example 2, use the appropriate rule to condense each logarithm. So here we want to combine these 2 logarithms into one using the properties. So if you notice here, we're subtracting, and so we can combine these with the quotient rule. So this would be log of 7x plus 6 divided by x. Now here, since I have a number in the front, we can take that to be a exponent. So I'm going to move it back as an exponent. and then we're subtracting. So I'm going to combine this using the quotient rule into division. And then this last one here, since we're adding, then this would be 25 times 4, which is log of 100. And we know that log of 100 is equal to 2. Solve exponential equations by expressing each side as a power of the same base. So if you have the same base, we can use the one-to-one property, which tells us that m will be equal to n. So the first step is to isolate the exponential part of the equation. Then we want to rewrite our equation so that it's equal to bm equals to bn, and then we set m equals to n and solve for the variable. Okay, so here I have 5 raised to the 3x minus 6 is equal to 125. I can write as 5 cubed. Now they have the same basis, so I can set the exponents equal to each other and solve for x. So I'm going to add 6 on both sides and divide by 3. So x is equal to 3. The next one, I have an 8 and I have a 4. So I can write this 8 as 2 cubed. And I can write the 4 as 2 squared. Since I have an exponent raised to another exponent, we can multiply it. So this would be 3 times x is 3x, and 3 times 2 is 6. And then 2 times x is 2x, and 2 times negative 3 is negative 6. They have the same exponents, so we can set the exponents equal to each other. So I'm going to subtract 6, and I'm going to subtract 2x. So I get x is equal to negative 12. Okay, on this one, the 15, no matter how hard I try, I will not be able to write that with a base of 4 or a base of 2. So this method does not work for this problem. So we need a different way to solve this. And so it's going to be using logarithms. So first we're going to isolate the exponential part. Of the equation. Then we're going to multiply by natural log or log on both sides of equation. Then we're going to use the log properties and solve for the variable. And that the last step is check your solutions. Okay, so here we have 4x equals 15. We cannot use the one-to-one property. That's always going to be the easiest method or fastest method. Since we cannot use that, then we're going to multiply by natural log of on both sides. So here I get natural log of 4x equals natural log of 15. I can take my exponent to the front using the power rule. And I'm trying to solve for x, so I'm going to divide by natural log of 4. So x is equal to natural log of 15 divided by natural log of 4. So this is an exact answer. But on the computer, sometimes they want a decimal answer, an approximation. So we would use the calculator. So we're going to have natural log of 15 divided by natural log of 4. And so our approximation is 1.953. 1.953. Okay, let's look at letter B. So the 134, I cannot rewrite that with the base 5. So I'm going to multiply by natural log on both sides. I'm going to use the power rule and bring the x to the front. Divide by natural log of 5. So x is equal to natural log of 134 divided by natural log of 5. And the approximation is natural log of 134 divided by natural log of 5, 3.043. Okay, the last one here. I can multiply by natural log again, or you can multiply by the log. Either way would be fine. So I'm going to bring my x to the front. Divide by natural log of 10. Okay, so the approximation is natural log of 8,000 divided by natural log of 10, 3.903. Okay, so for this one, you could also multiply by log instead. Since this has a base of 10, this has a little base of 10, and this is 10, this is 10, then our answer here is just x of log 8,000, which will approximate to the same number. Okay, so let's solve for the equation here. Since we have an exponential function, the 75 we cannot write as 5 raised to some number. So I'm going to take natural log of 5x equals natural log of 75. Bring the x to the front. Divide by natural log of 5. So we get x is equal to natural log of 75 divided by natural log of 5. So my approximation is going to be natural log of 75 divided by natural log of 5 is equal to 2.683. Okay, let's try letter B. So notice here that your exponential part, which is all of this, is by itself. So I'm going to multiply by natural log of 2 plus 7 divided by 25. 3x is equal to natural log of 4. Bring the 3x to the front since it's a power. And then I'm going to divide by 3 natural log of 2 plus 7 divided by 25. Okay, so the 3's cancel, that cancels. So I'm left with x equals natural log of 4 divided by 3 natural log of 2 plus 7/25. So approximation, we have natural log of 4. Let me go ahead and do this. Natural log of 4, enter, divided by 3 times natural log of 2 plus 7 divided by 25. Enter. So 0.5601. Okay, the next one. So here, this is E and this is E. They have the same base, so we can set the exponent equal to each other using the 1-to-1 property. So I'm going to add 6 on both sides. So I get 8x is equal to 10. Divide by 8. So x is equal to 10/8, which is equal to 5/4. So here I want to isolate my log first. So I'm going to divide this by 3 on both sides. So I get log 4 of 6x is equal to 3. So this is a logarithm, so I can change it to an exponential form. So this would be 4 cubed is equal to 6x. I'm going to divide by 6. So x is equal to 4 times 4 is 16 times 4 is 64 divided by 6. So this is going to be 32 divided by 3. Okay, so you want to check your answer when you're dealing with logs. And so the way we're going to check our answer is if we look at our original problem, if we substitute our answer that we got in for x, we want to know if this is going to be positive. And so 6 times 32 divided by 3, that is positive. And so this is going to be a solution. If it was negative, then we would not be able to say that it's a solution. We would say no solution. Okay, let's go to the next one. So here I can combine these two logs. Since they're being subtracted, I'm going to have division. Okay, so I can do the same thing here. Change this to an exponential form. So this would be 4 raised to the half is equal to x divided by x minus 1. Now 4 raised to the half, that's just the square root of 4. So if you put it here in the calculator, you'll see that you just get 2. Okay, so I'm going to go ahead and simplify that. So I'm going to write it as 2 is equal to x divided by x minus 1 multiplied by x minus 1 on both sides. Get x is equal to 2x minus 2. I'm going to go ahead and subtract the 2x. So we get negative 2 is equal to negative x divided by a negative 1. So we get x is equal to 2. We need to check our solutions. So this is the original problem. So if we substitute 2 for x, whatever is in here, if it's positive, yes, and whatever is here, 2 minus 1 is 1. So that's going to be positive. And so we can see that our solution would be correct. Okay, the next one, since we have a log with the same base, we can use the 1-to-1 property and set 3x plus 4 equal to x minus 10. I'm going to subtract x. So I get 2x. So I get 2x, subtract 4. So we get negative 14. Divide by 2. So x is negative 7. Okay, we need to check our solution. So if I plug in 3 times negative 7 plus 4 is equal to log of negative 7 minus 10. So negative 7 times 3 is negative 21, plus 4 is going to make this negative. Since it makes it negative, then we say that there's no solution. Okay, so these was using the properties to help us solve for x.